Determine which two functions are inverses of each other. In order for two functions to be inverses of one another, if we take the composite of the two functions, let's just say we're talking about f and g. If we take f of g of x, the answer has to be x. And also, when we take the composite of g of f of x, the answer has to be x as well. So what we need to do, we're given three functions in this case, and we need to find f of g of x to see if that equals x, and then we have to do f of h of x and g of h of x, etc., until we find the combination that gives us an x. So let's start by finding f of g of x. So what that means, remember, we're working from right to left. That means we plug the g function, which is 3x plus 6, into the x of the f function, which is x plus 6 over 3. So again, I take the 3x plus 6 and it replaces the x in the f function. So now this changes to 3x plus 6 plus 6, because we have x plus 6 in the f function, over 3. So when I combine like terms in the numerator, this gives me 3x plus 12 over 3. And since 3 divides it into all three, I can divide a 3 out. And this becomes 1x plus 4. Notice that our answer is an x. Therefore, f and g are not inverses of one another. So I'm going to try the next combination. I'm going to try g of h of x. So that means I take the h function and plug it in for the x's in the g function. So instead of having 3x plus 6, I'm going to have 3. Now I'm going to replace the x with the whole h function, the entire function, which is x minus 6 over 3 plus 6. So remember again, the g function is 3x plus 6. So in place of x, I just put in the x minus 6 over 3. So now let's go ahead and simplify. So in this case, the 3's reduce. So this leaves me x minus 6 plus 6. And x minus 6 plus 6, when I combine like terms, negative 6 and positive 6, that gives me x. So now to prove it, I need to find h of g of x. Remember, g of h worked, so we'll just check to make sure h of g gives us x as well. So in this case, we start from right to left, so we're going to take the entire g function, the 3x plus 6, and it's going to replace the x in the h function. So instead of it being x minus 6 over 3, the g is going to take the place of the x, so this becomes 3x plus 6 instead of x. We still have the minus 6, and that's over 3. So I'm going to combine like terms in my numerator. Positive 6 and negative 6 gives me 0. So I have 3x over 3, which reduces to x, and that's exactly what I wanted. So that means that h and g, or g and h, are inverses of one another. Only one-to-one functions have inverses. So remember, in an inverse function, what happens is that the x and y change places. The domain becomes the range, and the range becomes the domain. So we're going to change this from function notation to an equation. Remember, f of x is the same thing as y. So in an equation form, this is really y equals the cube root of x plus 4. So we're asked to find the inverse of x. So when we're finding the inverse, x and y change places, and we solve for y. So in this case, in order to find the inverse, I'm going to change this to x equals the cube root of y plus 4. Now I need to solve for y. So the first thing I need to do is get rid of the cube root. So in order to do that, I'm going to cube both sides. So this gives me x cubed equals, now remember the cube root and the cube cancel out, just leaving me with y plus 4. Since I'm solving for y, I simply subtract 4 from both sides, and that gives me x cubed minus 4 equals y. So since y equals x cubed minus 4, x cubed minus 4 is the inverse of the f function. Next example, we have g of x equals negative 4x plus 5, and we're going to find the inverse of this one-to-one function. So remember, the easiest way to do this is to start by rewriting it in place of g of x. Remember, g of x and y are the same, equals negative 4x plus 5. So in order to find the inverse, the x and y change places. So this becomes x equals negative 4y plus 5. And now I'm going to solve for y. So I'm going to subtract 5 from both sides. So this would give me x minus 5 equals negative 4y. And then I'm going to divide both sides by negative 4. So y would equal x minus 5 over negative 4. So the inverse of g would be x minus 5 over negative 4. If you're not comfortable with the negative being in the denominator, you can move the negative to the numerator and distribute it. So you can do one of two things. When you move the negative to the numerator, it becomes negative, or the opposite of x minus 5 over 4. Or if you want to, you can distribute it throughout, and it just changes the sign of both. So any of these three answers would be correct. Let's look at the next example. Again, we have a one-to-one function, and we're asked to find the inverse. So again, change it into an equation form. So we're going to change it into y equals 7 over 2x plus 1. Now the x and y switch places, so this would be x equals 7 over 2y plus 1. Now, since we have fractions in an equation, again, since I have a binomial in the denominator, I'm going to put that in parentheses. I'm going to multiply both sides by the LCD. The LCD, the common denominator, is 2y plus 1. So I'm going to multiply both sides by 2y plus 1. On the right-hand side, this reduces and just leaves me 7. On the left-hand side, that's x times the quantity 2y plus 1. I'm going to distribute. So this becomes 2xy plus x equals 7. Remember, you're solving for y, so I want the term, the 2xy, to be isolated. So I'm going to subtract x from both sides to begin with. So on the left-hand side, my y is isolated. On the right-hand side, I have 7 minus x. Remember, we want y to be by itself, so we're going to divide both sides by 2x. So this gives us y equals 7 minus x over 2x. So our inverse, the inverse of the h function is 7 minus x over 2x. Again, there's multiple ways to write the answer. The other thing that I can do is rewrite that into two separate fractions. So it'd be 7 over 2x minus x over 2x. And I can reduce. The x goes into the x one time. So that would give me, as a possible other alternative, 7 over 2x minus 1 over 2. Either answer is acceptable. In our last example, we'll do a similar problem. We'll be finding the inverse of n of x equals 8 over 5x plus 7. So again, first thing you want to do is express this as an equation y equals 8 over 5x plus 7. And then remember, x and y are going to switch places. So we're going to be dealing with x equals 8 over 5y plus 7. Since 5y plus 7 is a binomial, I put it in parentheses. Now I'm going to multiply both sides by the LCD, which is 5y plus 7. On the right-hand side, that reduces to just 8. And on the left-hand side, I have x times the quantity 5y plus 7. Now use the distributive property, and this becomes 5xy plus 7x equals 8. Isolate, so I want the term that has the y factor to be by itself. So I'm going to subtract 7x from both sides. This gives me 5xy equals 8 minus 7x. And then I'm going to divide by 5x. So remember, two possibilities. I could have the inverse of the n function equaling 8 minus 7x over 5x. Or I can reduce that, or rewrite that, I should say, and then reduce as 8 over 5x minus 7x over 5x, and the x's reduce. And so that would leave an alternative way to write your answer as 8 over 5x minus 7/5.